This is the second lecture on Unit 1 of Functions, and we're starting with Lesson 1.2 today, exploring the absolute value. Absolute values are a real number, giving no regards to either if it's positive or negative. So in other words, we pay no attention to the sign. Absolute values are indicated by two straight lines, like I have drawn here in red, like so, and that is read f of x equals to the absolute value of x. For any real number a, the absolute value of a is equal to a if a is bigger or equal to 0, and the absolute value of a is equal to negative a if a is less than 0. There are four fundamental properties of the absolute value. First one is non-negativity, in which the absolute value of a is bigger or equal to 0, which means that the absolute value of a is always non-negative. The second one is positive definiteness, in which the absolute value of a is equal to 0 if and only if a is equal to 0. Multiplicativeness. The third one is multiplicativeness, in which the absolute value of a times b is equal to the absolute value of a times the absolute value of b. The last one is subadditivity, in which the absolute value of a plus b is less or equal to the absolute value of a plus the absolute value of b. Next, let's look at inequalities of the absolute value. If b is bigger than 0, then the absolute value of a is less or equal to b, if and only if negative b is less or equal to a, which is also less or equal to b. The absolute value of a is bigger or equal to b, if and only if a is less or equal to negative b, or b is less or equal to a. So let's use the relationship that we just encountered into solving actual problems. Let's look at the problem of x minus 3 of the absolute value is less or equal to 9. This is only true if and only if negative 9 is less or equal to x minus 3, which is less or equal to 9. If and only if negative 6 is less or equal to x, less or equal to 12. Let's take a look at example 1. F of x equals to the absolute value of x for f of x is bigger than 2, and we have to graph that on the number line. Let's first ignore the absolute value for a sec and just look at f of x equals to x, for f of x is bigger than 2. If we were to graph that on a number line, then only the second part of this number line would be true. We draw a hollow circle at 2 because 2 is not included, but everything bigger than 2 is true. If 2 is included, then it will be a dot instead of a hollow circle. However, in this equation, we do have the absolute value sign, so everything that is less than negative 2 will also be true. As you can see, x is bigger than 2 and less than negative 2, and that would be the final answer. If you're confused, we can graph this on a graph of f of x is equal to the absolute value of x. You can see that the graph is comprised of two symmetrical linear functions, and they are f of x is equal to x if x is bigger or equal to 0. And that would be the graph on the first quadrant right here. And f of x is equal to negative x if x is less than 0. And that would be the graph right here in the second quadrant. You can see that no matter the input is negative or positive, the output will always be a positive value because we have nothing underneath the x-axis. So that's the end of this lecture. Remember that practice makes perfect, so please do your assignments and don't forget to upload your assignments.